I hope everyone has had a good morning. Right, good morning. Yes, my name is Nonhlanhla Kalabaela from the Water Research Commission. And I am a research manager there, and I manage a portfolio of research that is on water quality, but on the municipal services side. I'd like to welcome everyone else that is here physically, as well as those that are joining us online. You are most welcome. We have quite a not very long program for today. I hope that everyone has a copy of the program. It was attached as part of the invite, so I'm going to ask that you keep that handy so that we can refer to that from time to time. Right, I have some people here with me, so I do not think that really, in the interest of time, it would be maybe wise to go through a round of introductions, but some of them you will see them as they are part of the program, especially the project team, as they have a couple of presentations that they will be doing today, as well as in the last item, which is the panel discussion. There are other people that you will see that are going to introduce themselves. But for now, I will be the chairperson. I will be driving your program today. So just before we go any further, there are just some few housekeeping rules that I would like to go through. Maybe first, before we go that, I just want to make sure that everyone is in the right meeting. This is the knowledge dissemination workshop for the project on the use of effect-based bioassay toolbox for water quality safety and monitoring. That is led by a consortium of researchers with the University of Pretoria being the leader. And it is also co-funded by the Water Research Commission. Okay, right, now that we have gotten that out of the way, there are just a few housekeeping rules that I would like us to go through. The first one is, for those that are here, the exits in the case of emergency are marked. So I have one on my left, and there's another one on the right. And as well as the back of the room, there are some emergency exits. So everything that is marked with a green color, there's an arrow, and I'm sure you can then follow that arrow in the case of an emergency. And then for restrooms, they are at the back of the building. So at any point, please feel free to just step out and make use of the restroom. But we will have a comfort break just around 11:10. But in between that, please feel free to also just step out. And then I have already spoken about the program. So for our online participants, please feel free to drop in comments at any point, and then towards the end of the program, when we have the panel discussion, we'll pick up all the questions, and then we will try to get some of the researchers, or if it's a question that is directed to the WRC, I will try by all means to provide a response. And if I cannot provide a response at that point in time, I will maybe request your details, your contact details, so that we can then take it offline, and maybe I can then find a response for your question. And then the other thing is that I've already spoken about the comfort break that we are going to have around 11:10. And then we are going to then have the panel discussion, which will be the last item in our program, after which then we are going to then wrap up the session, and then it will be an opportunity to network, especially for those that are here, and then also do that over lunch. So that is our program in short. Just before maybe I call on the very first speaker, I would just like maybe just that we do just a run through our program together. So the very first item is a welcome. So I hope that everyone is settled in, and once again, welcome, and thank you for making the time to be part of this workshop today. We look forward to your interaction as well, as we would like some of your feedback on the approach that has been taken, or if you are really in practice and you still want to understand how to apply this method, would be more than willing to engage further after this event. And then after that, we are going to have a presentation by Professor Raleigh Peters from the Northwest University, talking about chemicals of emerging concern, human, animal, and environmental health in aquatic systems. And then we are going to have a presentation from the University of Pretoria by Dr. Natalie Anekhan, who is going to be talking about effect-based monitoring, the use of in vitro bioassays. And then around 11:10, we are going to take a comfort break, which is going to be about 20 minutes. So we ask that our online participants please stay with us until we come back. And then when we come back around 11:30, we are going to have another presentation by Ms. Lisette Sorgt. It's going to be titled Effect-Based Monitoring, and it will be on in vivo bioassays. And then after that, around noon, there is going to be another presentation from Dr. Natalie Anekhan, who is going to be sharing some feedback on a survey that was done earlier. It's either earlier this year or last year. And I understand that there is another survey that is out that is for your attention as well. So she is going to tell us a little bit more about that. And then at the end, then we are going to then take all the questions, comments, suggestions, especially from our online participants. That is where we'll try as much as possible to answer any questions that you might have on the project, the approach that's being taken, or any other question that is related to effect-based monitoring. And then that would bring us to the end of our program today. Like I said, then there will be an opportunity to network, and for those that are here, that will be done over lunch. So that is our program in short. So hopefully everyone is as looking forward to it as I am. So with that, then I would like to ask then that we start formally with the program. I'd like to call then our very first speaker, who is Professor Raleigh Peters from Northwest University. Aren't you going to give a round of applause? Thank you.
Thank you, Nonhlanhla. Good morning, everyone. So, I have the privilege to start off with this dissemination workshop. How do I get my presentation on there? Do I have to press the forward button? Yeah, it's there, but it's not there. There you go. Okay. Thanks. So, let's just start with it. My presentation is going to tell everyone give you a background as to why we need bioassays, or why we need to use biology to also check for water quality. And so, chemicals of emerging concern apparently can also mean contaminants of emerging concern, because if you check literature, the chemicals, I usually understand chemical as a compound that has an element in it, carbon, aluminium, whatever, but a contaminant also include biology, so viruses and bacteria. So for me, coming from half chemistry background, to say contaminant of emerging concern and then read the literature and see they talk about viruses and bacteria too, was a surprise. But apparently, the chemicals of emerging concern can be replaced with contaminants of emerging concern. So it really boils down to those compounds that are unregulated. So we know that, that there currently are a lot of guidelines for various elements and compounds that we find in the water. But emerging concern means it can be compounds that are known to us and we're not aware that they actually can be harmful to humans and animals. And therefore they are unregulated. And then there are also now compounds that we are not aware of. So the unregulated pollutants are usually present at levels lower than the limit of detection, and which is where biology is very well to detect. It can detect very low levels. But now, because we know of these compounds' ability to cause harm, we have now managed to create methods. By we, I mean research, not me personally or our team. Researchers worldwide has now developed methods to be able to detect these compounds at these low levels. However, it is a moving target. So as we speak, new compounds are identified as being harmful, and new compounds are being created to replace the current harmful ones, only to be found out later on that they actually are harmful too. All right, so let's look at different examples of what are these so-called chemicals or contaminants of emerging concern. First one I'm addressing are the nanomaterials. Now, before I run into this, I don't know how many slides of giving examples, I have to warn you beforehand that at the end there will be a quiz. And I will ask you to do some calculations as well. The very last 3 slides you have to add up stuff. So please pay attention. No, I'm only kidding. The sums are going to happen at the end, yes, but the quiz not, so don't worry. But what I want to say is that many of these chemicals or contaminants of emerging concern that I'm listing today is to give you a broad background of what they are. But the bioassays are not necessarily designed to detect all of these. All right, but I'll try to remember and point them out to you. One of them that's not necessarily so easy to detect or predict are the nanomaterials, basically because they are new to science. And there's a lot of research happening in the background to figure out exactly how to quantify their harm. All right, so nanomaterials are compounds usually smaller than 100 nanometers, which is very, very tiny. I mean, really. Just check your ruler and see what is 1 millimeter. So that can be natural and man-made. Fortunately, my presentation is big enough for me to see from here because I'm usually used to have a computer in front of me, and now I have to see what I've written there. Examples of the nanomaterials. This is not an exhaustive list, please. I mean, this is a broad field that's being developed. Carbon, silver, copper, gold, minerals and plant-based. And then a well-known one is the titanium oxide one. We find them in designer pharmaceuticals. I'll show you an image of such one later on. They are added to cement and cloth to make them stronger yet lighter. People, I cannot tell you where nanomaterials are all used. I mean, they occur everywhere that you can think of, in electronics, and they are actually also used in environmental remediation, and here I'm highlighting them as a chemical of emerging concern. And we use them to clean up the environment as well. So they're not all just bad. So the last 2 are examples of the ones that are used in pharmaceuticals. The second one from the right, the drug, can you see it says drug in the middle? It's where the medicine is contained within the shell and you drink it or it's injected into you and then it dissolves or it takes the medication to the point where it has to be delivered. All right, so now we get to the flame retardants. Now I hope I can recall all the acronyms. So the flame retardants, the brominated flame retardants, there are a number of categories of them. So this one, the category of flame retardants, these are the ones that we try to pick up with the bioassays. We find them in electronics, furniture, building material, anything that humans have to live in or survive on, usually have flame retardants in them because they slow down fires. Polybrominated diphenyl ethers are used the same as brominated flame retardants, but they are not chemically bound to the cloth or whatever you're sitting on, and they are easily released into the environment, into the air. They have caused lower birth mass and lengths of babies. So sometimes I also tell you what the bad news effect of these compounds are. I think the TBP, it stands for tetrabromobisphenol A. I'm just looking at Natalie and Slingeliswe. I think it's tetra, they are shaking their heads up and down, so it's right. It's used in computer circuit boards and electronics and textiles and paper. So you can forget all of this as long as the take-home message here is that it's all over the place. We are exposed to it our entire lifespan. Hexabromocyclododecaine are used in polystyrene and foam building materials. The Americans are great with this. They build their houses with the foam building materials. In South Africa, not so much. And then the organophosphate flame retardants. These are the newer ones, and they're supposed to replace the preceding ones because they apparently are safer. Again, we don't know what they're going to do, what harm they cause. Summary of the effects of the flame retardants. They are known endocrine disruptors. They damage the immune system, cause reproductive toxicity, are known to cause cancer, and cause adverse effects on the fetal and child development. And they also have neurological effects. Long list of things. That we are as healthy as we are, I think, is pretty amazing. All right, so now we get to the microplastics. This too is also a recent research focus worldwide. So not everything is well known about its harm. But what we know about the microplastics is that they do contain compounds that our bioassays can measure and can quantify. The thing about the microplastics is that they've got both, similar to the nano materials, is that they've got an effect on a physical front because they are not as small as a molecule, so they cause mechanical injury and behave different than an ordinary chemical, but they also contain a lot of chemicals, those that they are made up of and also those that they would absorb during their lifetime in the environment and then go on and release it at another place. So, synthetic solid particles, they can have a polymeric matrix. So, polypropylene, polyethylene, low density polyethylene, polyacrylates, again, you can forget all of that, it's plastic. They have a regular shape or an irregular shape. Sometimes, okay, you can see the size there. Sometimes they are created by purpose, on purpose, because they are used in toothpaste or a scrub on your face, or so they are created purposely. And other times they appear in the environment because of big, large clumps of plastic that break down into smaller pieces, and they end up all over the place. This is what I just explained. Some of them are primary and some of them are secondary. Primary means that they have been created small with a specific purpose in mind. And they're always insoluble in water. So if it's a primary one, they are used in fertilizers, they are used in plant protection products, in cosmetics, detergents, cleaning products, paints, products used in oil and gas industry. Ladies and gentlemen, I wasn't aware that it's actually this wide applied. I knew about it in the as personal care products. I knew about that, but I wasn't aware that it's used in paints and in gas and oil industry. So it's got a wide application. This image summarizes the sources of microplastics and how it ends up in our aquatic environment. I'm going to leave it there for another 10 seconds so that you can just look at it. There's no animation. So you can see from washing, personal clothes, detergents. I mean, if you look at your detergent, you often can see the small particles. And if you've got a washing machine, like we've got recently bought a new one, it's got a sieve that you can take out and check, and you can actually see the small particles on the surf, which is a surprise to me, was a surprise. All right, so all of this end up in our aquatic environment. That's the basin for everything. Okay, now we get to the agricultural chemicals. These ones are the ones that our bioassays are likely to have a response to. They include, again, a wide variety of compounds. You can see the list there, the pesticides, which is the collective name for insecticide, herbicide, fertilizer, bactericide, whatever the side is that you want to add onto the word, that's what pesticides all include. Some of them are more persistent than others, some of them are more soluble in water than others, but they all end up in the aquatic environment in some form. We also include the veterinary products here. You can see them, the antimicrobials, the antibiotics, antifungals, the growth promoters, and the hormones that are that the cattle are injected with, or that ends up in the chicken feed so that they grow faster. These things all end up in our environment. Okay, microbial contaminants. So this is the one that our assays are not focused on, because specifically these contaminants of emerging concern are those viruses and bacteria, or the snippets of it, their DNA, that is harvested from the water. So people go and investigate what genes appear of these bacteria in the water, and from that they learn that some of these bacteria are resistant to antibiotics. So that's also a concern for us worldwide, for us as humans, but for our own purposes in this today, this is not what we are focusing on to detect. Pharmaceuticals. Ladies and gentlemen, the problem with pharmaceuticals, smack bang into what our focus is on to detect their presence or their harm in the environment. They usually occur at low levels. But the problem with pharmaceuticals is that they've been created to have a biological effect. So they're supposed to have an influence on biota. But on an animal or a human that needs treatment, now they end up into the environment. And I listed a few of them. You can read them some of them are very familiar: diclofenac, ibuprofen. Some of them I can't even pronounce the words. Tramadol is an easy word to say, paracetamol, and so on and so on. Tamoxifen I can actually pronounce. Some of them are just difficult if you've got an Afrikaans tongue to try to say that. Okay, but this is not an extensive list. I mean, it's an example of pharmaceuticals. The problem is that there are now more than, approximately 4,000 pharmaceutical compounds known to mankind that end up in our environment. Some are completely metabolized, but some are not. This is an example of a summary of compounds causing endocrine disruptors. And here I'm talking about specifically pharmaceuticals and personal care products. I'm going to leave it there. I can't see the screen from where I have to do this. So you can actually see things that are common for us to use. You can see they contain compounds. If let's check the UV screens in the center column at the bottom. I mean, we're supposed to put on sunscreen if you live in South Africa. Check what is in there, and they are known endocrine disruptors. And we wash them off and they end up in our aquatic environment. You can see the veterinary growth hormones on the left here. If you read them, I mean, top left, you'll see the estrogens. Those are the synthetic pills that we drink to regulate female cycles or to prevent pregnancies. They all end up in our river system. I mean, and the thing is, the wastewater treatment plants have never been developed to remove all of this. Even in countries where they are working very well, they cannot remove all of this. And it ends up in the river, downstream, it's abstracted again for the next town's drinking water. Okay, so they have a wide variety of modes of action, which means that because they are medication, they have a variety of biological effects. The other thing about that second bullet that says combinatorial effects, it's something that goes for all of the chemicals in the environment, not just the pharmaceuticals. So an organism in the environment, or us downstream drinking that same water, we are exposed to a mixture of all of this. You can see there's an example of fluoxetine, that is a serotonin signaling that influences the serotonin signaling pathway. You can see what it causes in mussels. Now, I know you think that's just a snail, but it's part of the biology of the diversity in our natural environment. And if that organism disappears because of those effects, then our ecosystem can implode. The anti-epileptic drug carbamazepine, together with the lipid-lowering agent clofibric acid, has a stronger effect to Daphnia magna than separately. So they have a certain effect, but together they enhance their effect. Daphnia is a small invertebrate. Annika, what are they again? It's not a shrimp, it's a water flea. That's the ordinary word. Thank you very much. Yes, Lizette. So they occur naturally in our environment, and they are the food for organisms higher up in the ecosystem. Diclofenac, look at the low levels, micrograms per liter. It affects the kidney and the gill integrity and the immunity of brown trout. And then sometimes the metabolites of these compounds can be more harmful than the original. Personal care products. Hey, ladies and gentlemen, if you're a human being living in 2022, you are familiar with these: hair dyes, cosmetics, creams, deodorants, bath soaps, dental care products, shampoos, and the list goes on. Triclosan and triclocarbon, those are the compounds that are added into some soaps. They are microbicides, they are harmful. Triclosan specifically is toxic to aquatic species. Parabens is a preservative in makeup, and it's in moisturizers, and you can see, and it's harmful. It's a known endocrine disruptor. So, this wasn't an exhaustive list. This is just to tell you exactly why we are doing what we're doing in this workshop today. The issue is that there are so many compounds that we should test for in the water, our tap water, as well as all sorts of other types of water. And by types of water, I mean irrigation water, water that we fish from, water that we swim in. Those are all the types of water I'm talking about. It's almost impossible to test for the list of compounds that can be there. And even if we could do that, we are not aware, we don't know what are the effects, the biological effects. Even if it was possible, even if it were possible to quantify each of these compounds on a regular basis, you still cannot tell anyone what are the biological effects of these compounds are on the organism, drinking it, swimming in it, living in it. So that's why you always have to combine your chemical data with biological effects. That's a given. You cannot move away from that. Now, the second bullet there says monitoring of all water types. Of course, the quality for drinking water should be high, higher than I think you would use the water that is supposed to go to feed cattle. All right, so those I've addressed. I forgot that I actually have this animation there. Okay, now this is where you get to do some maths. I know you can barely see there. This is a summary of all the compounds that currently South Africa is worried about On the left, far left, you can see a list of compounds: aluminium, ammonium, antimony, arsenic, atrazine, barium, beryllium, blah, 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 and the list continues. If you go to the right of this table, you will see the different types of water. And on this table, the guideline levels that are currently applicable in South Africa are listed. And of course, you'll see domestic use, the recreational use. Apparently, we don't need any quality control for the recreational use. I think some of the inscriptions come in the lower down on the table. And this version here, on this first slide, that column is empty. The industrial use has certain levels that should be met for the various compounds. Now, I just want to see what's happening. Okay, so now you start counting. So there are 3 slides now. This is the first one. The squares indicate which elements we are supposed to quantify. All right, so I think it says 4 there. I've omitted, I'm not counting the nitrates and the phosphates. Those are the things that people are regularly testing, and we can do this on a regular basis. It's easy enough. But I'm now talking specifically about the elements and the harmful compounds, the organic compounds. So 4 now, and then there's 5. Okay, and then there is another 5, and then I think it's 6. So we are now, on this page, we are now down to 20 elements that we are supposed to quantify. The organic ones, you can count them. There's atrazine, it's a herbicide. Cyanide, I put that in, I'm thinking that it's tested for usually, so I don't think that's a real issue, but because it contains carbon, I put it in as an organic compound. And then endosulfan, which is an old pesticide. Apparently, I think it's banned, but it's still on the list. Now we get to page 2. So the previous one had 10 elements, and what was it? 3 organic compounds. Here we count again, 4 plus 6 plus 1 elements, and phenol, organic carbon compound, and only 1. And then here on this page we count 3 elements again, and most of them are metals, and I understand why. We are a mining country and we should check for them, and many metals are harmful. And then the total organic carbon, and which isn't really part of the compounds, and then the trihallomethanes, usually 4. In South Africa we test for 4. Those are the byproducts that are created when bromine and chlorine are added to water to make the water purified so that we can drink it. I mean, remove the bacteria. Now, I ask you with tears in my navy blue eyes, how are you supposed to make sure that a country's water is looked after when there's only this limited number of compounds that we try to quantify? And yeah, so, and this is why we want to use the biology because the biology responds to the mixture of all of this. So you can predict or use the biology to say that the water is useful for irrigation or for human consumption, because the biology says it's safe. We don't necessarily know all the compounds present in the water, but we see that the biology that we use to test for it is okay. The biology says it's okay, and then we can consume it. I know it's not that easy, and this is where Natalie comes in to explain. Natalie and Lisette, they're going to tell us why, like anything in life that's worth doing, it's not easy, but someone has to work on this and create methods and battery of biology tests that can be used in addition to chemical analysis. And with that, I'll stop talking.
All right, thank you, Prof, for that presentation. I hope that someone is keeping tabs on the online participants if there are any questions. But like I said, that we'll have a chance to tackle those questions towards the end. The next speaker is indeed Natalie, who is going to be speaking about the use of effect-based monitoring, and she'll be focusing on in vitro bioassays. Over to you.
Thank you, Nonhla. Good morning, everyone, and good morning to everyone online this morning. Thank you for attending my workshop. If I could have my presentation, please. Okay, so today I'm going to talk to you about the bioassay toolbox for water quality assessment in South Africa. This is a project that we've been working on now for a couple of years, funded by the WRC, and it's 00165. That is what we're going to focus on today. But just to also reiterate what Rialetta said this morning, is that the WRC's Research and Development and Innovation Roadmap 2015 to 2025 indicates that the demand for water will outstrip supply by 17% by the year 2030, which is actually not very far away. And South Africa is then obviously faced with challenges of ensuring a sustainable and safe water supply, particularly drinking water to the community for community health development and also to ensure a good economy. We've spoken now this morning a lot about the chemicals that are released into the environment, and some of those might be endocrine disrupting chemicals and are suspected to be photochemicals. They biotransform and also result in multiple transformation products. So it's not just your parent compound that we're looking at, but it's also their breakdown products. These micropollutants or contaminants have been detected in what we call pristine water sources at low levels. So essentially there are really no pristine water sources left in the world. And we also find this also in source and treated drinking water, showing that the water treatment processes are not necessarily efficient in removing these contaminants from the water. And then also from the drinking water treatment processes, there's disinfection byproducts that are added in order for us to be able to drink the water. And then these are also transformed into micropollutants. Advancements in the chemical analysis today has come very, very far since we started, and they are able to detect chemicals in parts per trillion and lower concentrations. But there are limitations because there is a near infinite list of analytes, and there is also, despite that, also potential for mixture effects. So we've been researching quite intensely on how to apply in vitro bioassays that are commonly used in pre-screening stages of drug development to water quality assessment. So it's assays that have been used very often to test either individual chemicals or individual chemicals in a set mixture. But we want to apply it now to our environment. So just to give you some historical perspective on how long this endocrine disruption research has actually been taking place, it started back in 1999, where a lot of water stakeholders wanted reliable and relevant data. Sorry, I can't put my glasses on because the screen is a bit far, and so I'm missing a word or two as I'm reading. So relevant data on EDC levels in the South African water systems. So the WRC really stepped in at this point, and we held a workshop where it was then decided that we would launch EDC research through developing a strategic research plan. initiated as a result of a workshop held back then. And that was a water consultancy K8477. And we wanted to see what the status of the information was in South Africa, and also to assess the capability and capacity of laboratories to generate data on chemical and biological analysis of these substances. And as I say, it was started by Ms. Ansi Berger back then, but now Nonhlanhla has largely, I think, taken over the role of promoting our EDC research. So the first efforts were to conduct a research program looking at universities and technikons, also the water treatment sector, government departments, parastatal research institutions, and getting everyone together to develop this program, which was then presented in 4 parts. Volume 1 was strategic planning, and that was to develop the research plan. Volume 2 was an implementation of the research plan in 2 phases, and it resulted in a consolidated report to give us the status. And then once we knew what the status of the information was, and the research was, and the knowledge, we could then do our strategic planning, which then took another 4 years to work through. And then the implementation phase started largely between 2006 and 2010, and has been ongoing since then. So one of the first things we did was we held a workshop to develop a training manual, or SOPs, on the types of bioassays and sampling guides and things that we would need to be able to continue this. So volume 1 looked at the monitoring and assessment. What was monitoring, how were we going to monitor it, and how were we going to assess it. Sampling guide was looking at very careful sampling procedures for these bioassays, because that is quite a critical step. And then looking at the bioassay methods available at the time, focusing on the identification, the selection and standardization of the assays. And at the time, the most common assays that were available was for estrogenic compounds. And then volume 4 was to cover the management options. So our focus was the bioassays. At that time, the Global Water Research Coalition was also looking into developing a toolbox for estrogenic activity globally with their global partners. And workshops were held, and the WRC was part of that, and sent some of the scientists over, and we came up with 5 tests, all for estrogenic activity, because that was what was available at the time. And these 5 tests were then presented for the global picture. But South Africa does not necessarily have access or the funding capacity to do some of those bioassays, because they are incredibly expensive, some of them. So we had a look to see what was available here in South Africa and what we could propose for our first toolbox. And we came up with the yeast estrogen screen, a mammalian cell line screen, the T47K Blook, the E screen, which is a proliferative assay, and then the fish VTG, which is a hormone produced by the fish. And this also included a section then on, a very basic section on chemical analysis. So through the years, we've worked in conjunction with the WRC and GWRC. When the toolbox came out for the GWRC in 2008, our one came out in 2011, specific for South Africa. It was then expanded by the GWRC to include other endocrine endpoints, not just estrogenic. We looked at androgenic, thyroid, and other aryl hydrocarbon, assay, so there were a number of assays that were included that had different endpoints in Toolbox 2. We were able to set up the thyroid assay here, which was an important assay at that time and considered to be a required assay. So after that, we've now got these toolboxes. What do we do with them? And again, the partners came together in 2018 and said, now we've got all these assays, we need to be able to apply them in some form or way for water management. And it was a complete paradigm shift in a way. The WHO was also shifting their water safety plans into something more functional. So they came up with the effect-based monitoring program in water safety plans. And they approached us and the WRC, and with Nonhlanhla's support, we are able to now also, in parallel with them, do this project that looks at not only updating our first toolbox, but actually putting a toolbox together for these bioassays that can be used for effect-based monitoring. Why do we say that chemical analysis is not also the only way to go? There are limitations because there's, as Rialette pointed out, there's an infinite number of chemicals and their transformation products to test, which is not always possible. And sometimes the water can differ. The chemical pollution in the water can differ in various areas, if it's industrial or farming or urban, rural. So it's very difficult to account for all the chemicals and their transformation products. But more importantly, it cannot account for the mixture effects at a biological level. So in the last 20 years, there's been a large body of literature that has applied in vitro bioassays to water quality assessment, giving us a wealth of information regarding the strength and weaknesses and suitable applications of these bioassays, and also improvements in the bioassays that are available and their protocols. These studies have also shown the suitability of a suite or toolbox of in vitro assays to assess water quality. So you're not only looking at one mode of action or effect, you're looking at a biological effect of different effects. And this obviously can give us the added benefit of a more comprehensive water quality evaluation, which is really great. Needless to say, it's not the only answer. There are limitations to this approach. And one of the things is the issue of sample collection and preparation. It needs to be done in a very specific manner, which we do highlight in our toolbox. There needs to be a certain form of quality assurance. But also, on top of that, is the interpretation of the in vitro assay results. This seems to be also a crux globally. In fact, I'm going to a workshop later this month where this is actually going to be discussed as part of the final part of the GWC product, is how do we interpret these bioassay results and how do we use them on a global scale so it can be comparable around the world. And also, it's what do we do when they don't necessarily imply an adverse effect in an exposed whole organism? Where do we go from there and what is the next step? Also for regulatory and end user concern about how they are applied. So because you're looking at more than one assay, more than one endpoint and different water sources, you can't use everything for every type of water. It's just not economically viable, but also capacity viable. So, but why do we want to look at the biological effects? We alluded earlier to trace levels of chemicals because they're there in a mixture and they're there below their no observed effect levels. What happens is you get the multiple or group of chemicals together that may have a similar mode of action, and individually they don't have any action, but once you put them together with the same mode of action, you can actually get a something from nothing effect, or a concentration addition effect. So it's not a 1 + 1 = 2. It's a 1 + 1 = 5 or 10 effect. And here we're talking biological effects. So we're talking, for example, estrogenic action, oxidative stress, and those different types of modes of action. So individually, when you do the chemical analysis, the chemical itself is there and it's in the guideline level, but because of the mixture, it has an adverse health effect. And this is why it is important to look at applying effect-based monitoring for water quality assessment in parallel with chemical assessment to a certain extent. So we apply these bioassays to your different water samples, source water, wastewater, recycled water, drinking water, groundwater, you name it, we can apply to these different types of water sources. But you will use a selection of bioassays guided by the principle of an adverse outcome pathway, which, and in order to cover all the relevant steps in your toxicity pathways, known to be triggered by environmental water samples with these chemicals. So the bioassay results are usually expressed as bioanalytical equivalent concentrations. And how do we do this? Usually, depending on the assay, you have a reference compound, and the effect of the sample is then compared to the concentration of the reference compound. And that would elicit the same response in the mixture of chemicals that you are testing. So for example, if you are testing a sample for estrogenic activity, you will express it as estradiol equivalents because your positive standard in that case will be estradiol, 17-beta estradiol, the natural hormone. So effect-based monitoring for water quality assessment will apply your in vitro assays using different types, mammalian cell lines, bacterial strains, and yeast cells. And also including now, we are looking at in vivo bioassays to complement these chemical analyses that we are doing. So the bioassays are a potential solution for assessing complex samples and screen for total bioactivity of the given sample via a pathway or mode of action along the adverse outcome pathway. It's not very clear, but on the graphic you will see it talks about a toxicant, a macromolecular interaction, and an initiating event across the toxicity pathway. And this is what we basically are measuring with our bioassays at various levels. So they are very often, those that are used for endocrine disruptive endpoints are receptor mediated, and you get the basic receptor binding assay. This will just tell you whether the compound binds to the assay or not. It doesn't tell you anything else. Whereas most of our assays that we are looking at are reporter gene type assays, which then will not only show the binding to the receptor, but also metabolizing from there on. So it'll give you a more complete picture. Cell proliferation assay is usually if you have an estrogen and you add it, the cells will multiply, showing an estrogenic activity or an agonist activity if you co-incubate with an antagonist. So the GWRC came up with a list of endpoints or modes of action for their in vitro bioassays, looking firstly at xenobiotic metabolism. There they selected the activation of the aryl hydrocarbon receptor. It is a good receptor for metabolic effects. Other ones that you can include there are the activation of the peroxisome proliferated assay or the progesterone or pregnone X receptor. But these assays are actually not available in South Africa except for the aryl hydrocarbon, which is not the AHRK, like it's a different cell line, which I will talk about now. So that we will look at for metabolic effects. Then we will look at the hormone receptor-mediated effects, and that we are looking at more steroidal effects for your estrogenic activity. There, in those mammalian cell lines that we use there, we can use agonistic or antagonistic tests. Agonist means that the compound binds to the receptor that you are investigating, and it has a normal trigger-on effect. So it will mimic the effect of the hormone. If it's an antagonist, it will go in and block that receptor, and the receptor will not be able to function, and it will, for example, if it blocks the estrogen receptor, it actually can cause an anti-estrogenic effect, but ultimately in the end an androgenic effect. We see that with androgenic receptors, something like bisphenol A. In the estrogen assay, it acts as an estrogen agonist, but in the androgen assay, it acts as an androgen antagonist. So it has a dual action, but ultimately in the end, the effect is an estrogenic effect. Then also they have adaptive stress response assays looking at oxidative stress, and the P53 response and the NF alpha beta response assay. None of those are actually available in South Africa at the moment, but we are looking at that. So what have we got in South Africa that is available to us? The in vivo. I'm concentrating so much on the in vitro. They've also proposed in vivo tests for reactive toxicity and apical effects. I'm not going to cover that. Lizette will cover that in her talk. I'm focusing just on the in vitro. So what have we got here for us in South Africa? What did we propose as a team for our toolbox? Well, we're looking at xenobiotic metabolism. There we have the aryl hydrocarbon assay using the H4 IE look assay, if my eyes are not deceiving me. And then we have hormone receptor-mediated effects, where we have got cell lines for the estrogenic activity. We have a yeast cell line and a mammalian cell line. Androgenic activity, also a yeast there and a mammalian cell line. The difference between that is the yeast is an extremely robust assay, so it's good for certain types of water, and the mammalian cells are far more sensitive, and they have 2 receptors in them, so they are better sensitivity-wise for your treated water. We also have thyroid activity assay, the GH3 tray look, available for the thyroid activity, and we are in the process, both at Northwest and at UP, of establishing adapted stress response assays, looking at oxidative stress. Rialette and them are looking at establishing the malondialdehyde assay, and we are working with Beate Esho on the ARE32 bioassays. And then the other 2 highlighted in blue there are part of the in vivo assays. So to make it easy for our water stakeholders, we put together a report that contains assay fact sheets, where you can get a quick summary if you want to have a look and see what is this about, what are we going to need, what is the equipment, what sort of samples. The fact sheets are available in volume 1 together with the literature review. And the toolbox that we've actually put together now not only updates our estrogenic toolbox, but it also, with other endocrine disruptive assays, but also we have now the group of additional assays that are recommended to be used in effect-based monitoring. for example, like your adaptive stress and xenobiotic metabolism. This is a very big table. You won't probably be able to see much here. At home, those looking online might see it a bit better. But this table also will be found in the report, and it lists the assays that we have available in South Africa. And also it gives a comparison on what kind of skill is required. Are they easy to do, relatively easy in obtaining materials? What sort of equipment you need, how complex they are, and what sort of waters they can be applied to, and then the price at the current time. So that can give the water stakeholders an idea. One of the issues we do have in South Africa, I think, is a capacity issue, but I'll cover that a little bit more later. Why do we want to look at and use these assays for effect-based monitoring? Because they detect all the chemicals in the water sample that are active in an applied bioassay, including both the known and the unknown. They account for the mixture effects, and sometimes by having a look at what's been on the chemical screen, and that's not looking at individual chemicals, that's looking at what is potentially present in the water chemically, you can also then use that with your bioassays to see, is there a group of chemicals that we are looking at here, which also then gives the chemists an idea of what chemicals they need to go and look for. And it can then also explain to us the kind of effects that we are seeing, especially if we're using different modes of action. Assays. It can also be applied as a screening tool, and particularly it is going to be used, I think, quite a lot for input for risk-based monitoring programs. It's very useful. We developed our effect-based trigger value or for estrogenic activity using our estrogen assays. So it's useful for that. Then it can be high throughput, what is considered high throughput assays, using 96 or 384 well plates. So we've got all these assays, but what is very important about this? We need to be able to know at what level of response do additional actions have to be taken. It's all good and well having all these tests and they give us an answer, but we need to know what to do with the result. And the proposed method is to develop benchmark values, termed effect-based trigger values for the different assays. ESHA published a paper recently discussing the options to derive the EBTs, and this is what's going down in the European Water Framework Directive, and it's proposed that these values will be an anchor to bioassay responses in a chemical context, but also to tell us whether we need to have further investigation, either chemically, technically, or operational means at the water plant. So these are going to become quite essential values to us in the end. The application of this in water quality assessment is to be able to assess the quality of the water, environmental, final product, or of the water treatment plant. You can test water efficiency, so you can compare your source water to your final product, the process of treatment. So there are a number of ways that these assays can be applied. And there's a sort of decision tool that you can use to decide what sort of bioassays you are looking at, depending on the product that you want to get out of in the end. So you would use a number of tests, looking at relevant bioassays and a more practical design. So if you are a lab that doesn't have a sophisticated, or a treatment plant without a sophisticated lab, you can do the basics. If you want to test for more, you're going to need a more practical lab. So you will then test, say, 3 of the types of assays. And so if you want a comprehensive test or battery, then you will add as many assays as you can. But you will also look at the product that you're wanting to test. So, for example, if we're looking at product quality, we will, and that is looking then at product water of treatment, drinking water, and I can't see the third one there, but environmental water, then you will test the product. So for the treatment process, you will look at different steps of samples there. And your sampling is also very much going to, your campaign is going to determine what samples you are going to collect. So what you want to measure is going to say, okay, I want to measure effluent, this is what I'm going to put into my test of assays. And we hope to come up with something more definitive at the end of the project. So we finished now with 00165 with our toolbox, but it has to be applied to see if what we've put together works. So together with UNISA, there's 2 more projects going, 348 and 347, where we will work together with UNISA. They're doing the chemical analysis, we're doing the bioassays, and we will do various case studies, and also keep updating the toolbox as necessary if we have to. But in closing, I just want to say we've come a long way. And we still actually have a very long road to travel. And we need, some of the things that we need to do are assay standardization and implementation. Not just here, but globally. We need to develop EBTs for South Africa because our population is different to the international population. We realized that we don't have enough awareness and education as far as this is concerned. It's been a highlight of the project so far. Capacity building with human and infrastructure, that is, I think, a big stumbling block for us, which we need to work on, but we have some ideas on that. Currently, as Rialette said, there's no policies and regulations really, or they're very limited. And we need to be able to empower the stakeholders to also come to the party and insist that this needs to be looked at and have government support. So thank you, everyone. That's me.
All right, thank you very much, Natalie, for that historical perspective on EDC research in South Africa, and also giving us some insights on where we are headed, including what is currently being done at the moment. I know you spoke about a report or a project 00165 that has just been completed. I wish I had good news that the report is available on the website, but not yet. But it will be very soon. If you also are like me, you still need to read everything in writing, everything that Natalie has said, so that we can have that deeper understanding on bioassays. Because I think whether we like it or not, it is going to be the future of water quality monitoring. I think when I started introducing myself, I did say that the portfolio of research that I'm currently managing at the WRC is on the municipal services side. So this project is very important. As you know, that South Africa is a water scarce country. So for South Africa to be able to diversify into other alternative sources of water so that they can be used for drinking water production, we need to start having a better way to manage chemical contaminants of concern. So the risk-based monitoring that probably you've been hearing about since morning will in the future be based to a large extent around this very work or this very approach of effect-based monitoring. All right, yeah, we could talk for the long day. I see that there is a question.
No question. Sorry, Dr. Hunter, to interrupt, but City of Cape Town is having problems with the link. And I have tried with my limited technical abilities to help them. But I don't know if one of the ladies can maybe.
Okay, I'll go.
Swastika has just been sending me messages saying that they can't.
Okay, I'll go.
All right.
I think it's very important for them to hear this.
That is correct. You are quite right. Yeah. So yeah, we'll try to. Unfortunately, maybe we missed them for the morning session. Those that have had problems to log in using the link. But I think the good news is that the session is recorded. So hopefully they will be able to catch up during their own time, listen to some of the presentations that we've had this morning. And like I said when I started, that I think the project team is also more than willing to engage even on the sidelines on this project, because like I said, it is very important that we all develop a certain level of understanding on effect-based monitoring, as well as the application of these methods for water quality monitoring. As I had already stated, that this is where water quality assessment or water safety planning is going in the future. All right, while we're sorting out the link problems, we have reached that stage where we should break for about, I would say, we were supposed to have this break around 11:10. Now it is 11:33, so we are running behind by about 23 minutes. So I would say that probably we limit the break to about 10 minutes or so, if we can. So I would just maybe fast forward my watch and take it that we start the break at 11:35 so that we can be here at 11:45. I hope that is okay with everyone. All right, see you shortly then, 10 minutes, just to stretch your legs and grab yourself a cup of coffee. And then after that, we are going to resume with the rest of the agenda items on our program. All right. We are going to resume with our program, and the next presentation is by Lizette Swart, who's going to talk about effect-based monitoring, focusing on in vivo bioassays. Over to you, Lizette.
Yes, sien of ek kan sien. I'm not going to be able to see. Yeah, good morning, everybody. As Nonhlanhla said, I'm going to talk about the in vivo bioassays. As Rialette mentioned, South African surface waters contain hundreds of thousands of chemicals, including pesticides, biocides, pharmaceuticals, surfactants, personal care products, and many other chemicals, but not only the individual chemicals, but also the transformation products. I think I can skip this because a lot has been said already. These chemical cocktails pose a risk to ecosystems, and they raise concerns for human health if the water sources are used for drinking water and for recreational purposes and fishing. So I just want to say again that due to the rising number and the diverse nature of chemicals that are used in the different industries and in different processes in South Africa, the normal practice of using single chemical analysis for water quality assessments, although they may prove valuable in water resource management, they have been found to be flawed because of the difficulty in predicting toxicity as a result of the interactions between these individual compounds. And then the challenge in South Africa is to characterize the chemical pollution in a comprehensive way and also with limited resources that we have, such that the impact of the pollution can be fully assessed and that risks to ecosystems and ultimately human health can be prevented. That resources for safe drinking water production can be protected with limited treatment costs, and that improvements through programs of measures can be monitored. We've talked about this as well previously, but I just want to note again, there's a few additional ones, just the disadvantages of using the single chemical analysis. As we said, that water pollution is a complex situation that involves a vast number of diversity of chemical substances, and many of them are unknown, and they will not be included in routine testing regimes, as been noted before. Chemical procedures cannot detect all possible harmful chemicals which might be present in the water. Chemical characterization of water or effluents can be very expensive if you have to look at all the substances. Chemical procedures cannot predict the effect of exposure due to the combinations of all the chemicals present, as we noted before as well. Sometimes the substances display significant tox effects at levels that are so low that they cannot be detected by normal chemical analysis. And chemical analysis can also not predict the potential long-term effects of toxicants. So that's why we thought that we needed to introduce these methods, these in vivo methods where whole organisms are used. Living organisms respond to the total effect of actual and potential disruptions in water, and therefore the use of these tests has become an important approach to complement chemical analysis to detect and quantify the effects of groups of chemicals on toxicological endpoints of concern. Now, I've just noted there that in the USA, the EPA uses an integrated hazard assessment scheme in which biological toxicity tests play a key role. And the use of bioassays to control toxicants in industrial effluents and related receiving waters is also advocated by the OECD. And in South Africa, where industrial effluents and hazardous waste has become a growing problem, the demand for biological tests for water testing is also rapidly increasing. And the importance of whole effluent toxicity testing as an appropriate tool to assess the suitability of hazardous effluents for discharges into receiving environment has been acknowledged by the Department of Water Affairs, and they've subsequently started requesting industry to have their effluents evaluated by using These tests, they've started including it in water use license requirements for monitoring of effluents and also discharges and now also natural water resources. In vivo toxicity tests are helpful for a whole range of things that we mentioned here. They link chemical and ecological status. They detect the effects of mixtures and demonstrate their potential to affect aquatic organisms and ultimately human health. They minimize the risk of overlooking hazardous chemicals, as well as the impact of the transformation products and chemical mixtures. They demonstrate whether contaminants is bioavailable, because the mere presence of a chemical that you pick up in a chemical analysis doesn't mean that it's available for uptake. And also things like, for example, the presence of abrasives in, like talc in pesticides, it affects the outer structure of the organism, which makes it more susceptible to uptake of chemicals. Then they evaluate the aggregate toxic effect of all contaminants in a medium. They evaluate the toxicity of substances whose biological effects may not have been well characterized before. They characterize the nature of a toxic effect, so is it a lethal effect or a sublethal effect? They characterize the distribution of toxicity at a site for investigative monitoring, and they also have a role in developing remedial guidelines and determining a site's post-remedial potential to support viable ecological communities. So just looking at these tests, aquatic toxicity testing is the process of determining the degree to which a substance of interest negatively impacts the normal biological functions of an organism, given a certain exposure duration, the route of exposure, and substance concentrations. Toxicity tests, as I mentioned, can measure lethal or sublethal effects, which are measurement endpoints, which are ecological attributes that may be adversely affected by exposure to site contaminants and that they are readily measurable. So they can be, we can distinguish between acute toxicity, which are short-term tests, and the measurement endpoint generally reflects the extent of lethality, and chronic toxicity tests, which are longer-term tests that measure the effects of exposure to relatively lower and less toxic concentrations. And the measurement endpoint concerns a sublethal effect, which can be anything like production or growth or ingestion, or both lethality and sublethal effects. So if we look at acute toxicity tests, a typical acute toxicity test exposes test organisms to a series of dilutions of a site's medium, and it records deaths over a specified period of time. It can be anything from 24 to 96 hours related to uncontaminated media. Alternatively, results of an acute test can be analyzed to estimate the dilution of the medium at which 50% of the organisms died, and that is noted as the LC50, and it's the dilution of the medium lethal concentration. But with some organisms, it's difficult to determine death unequivocally, and in such cases, other effects such as immobility that correlates closely to death is evaluated, and that's noted as effect concentration, or EC50s. And then in another approach, data is evaluated as the lowest observed effect concentration, which is the highest dilution causing statistically significant toxic effects, or the no observed effect concentration, which is the lowest dilution at which no statistically significant effects occur. Looking at chronic tests, chronic toxicity test exposes test organisms also to a series of dilution of a site's medium and measures sublethal effects. And those can include growth reduction, reproductive impairment, nerve function impairment, lack of motility, behavioral changes, or even structural abnormalities. Results are analyzed by direct comparison between percentage effect occurring in organisms exposed to site media and those exposed to uncontaminated media. And other approaches include determination of EC50s, the LOEC, or the NOEC. But now it's also important to note that the sublethal effect that chronic tests measure in laboratories must also be extrapolated to ecologically significant effects when they occur in the environment. So effects like reduced growth can lead to decreased production, smaller size, lower number of eggs and young per female, and increased susceptibility to predation as well. And reproductive impairment can reduce the population size and also bring about changes in the population's age structure. Production of individuals with structural abnormalities can adversely affect the population because these individuals have a lower growth rate and are generally unable to reproduce and have an increased susceptibility to predation. So it goes much further than just the obvious. Then the effects of pollutants present in the sample are assessed by bioassays with selected species, and these species are all representative of the trophic chain of production, consumption, and degradation. So similar to biotic indices, which they use during biomonitoring, various toxicity classification and scoring systems have been developed in South Africa, but we've standardized by using the ToxKit microbio tests because of their low cost, their quick response, their ease of testing, and their high sensitivity. And then there's also a related classification system that was developed by Persona et al. Toxicity testing done as per the Department of Water Affairs DEEP protocol uses these test organisms from these different trophic levels because they are all sensitive to different substances at these different trophic levels. So the more different organisms from different levels you include, the more accurate your hazard classification will be. We decided on the normal ones that are used at the moment in South Africa is the bacteria test, the microalgae, the macroinvertebrates, and the vertebrates. But we have also added an additional one, alternative plant test, the duckweed test. We've been experiencing some issues with, or not really issues, but there's a lot of things that can interfere with your algae test we've seen to date. So we just added the alternative to see if that might not be a more suitable test. And then also a rapid screening test, the thamnocephalus test. So I've just made a summary here of the different tests. The Vibrio test, the bacteria test is a sublethal bioluminescent bacteria test. The EC50s are calculated based on the amount of inhibition for the different concentrations. It's an excellent screening tool and it's got good sensitivity to a wide range of toxicants. I think the last time I read it was up to 3,500 different chemicals that it is sensitive to. Disruption of the respiratory process by exposure of a toxicant affects the metabolic pathway that converts chemical energy via the electron transfer system of the bacteria to the visible light. So we read the stimulation or inhibition of light emission. Then the sublethal algal growth inhibition test using unicellular algae is applicable for toxicity screening of chemicals, effluents, sediment pore waters and elutriates, surface and groundwaters and wastewaters. Monospecie algal strains are cultured for several generations in a defined medium containing a range of concentrations of the test sample, prepared by mixing appropriate quantities of growth medium, test sample, and inoculum of exponentially growing algal cells. And the test batches are incubated for a period of 72 hours, during which the cell density in each test solution is measured at least every 24 hours. And inhibition is measured as a reduction in specific growth rate related to the control cultures under identical conditions. Then for the invertebrates and the vertebrates, also applicable to screening of chemical substances, industrial and sewage effluents, treated and untreated wastewaters, aqueous extracts and leachates, surface and groundwater, eluates of freshwater sediments, and pore water of freshwater sediments. It is based on the exposure of the young of these organisms to the test samples, after which the immobility or the deaths of the organisms are counted and the LC50 values calculated. Then the duckweed test, which is the alternative one, works basically the same as for the algae, exposure and then measurement of growth inhibition or growth stimulation. And the rapid screening test using Thamnocephalus, it's a cyst-based toxicity test for rapid screening, also of chemicals, effluent surface and groundwaters and wastewaters. It's a rapid bioassay performed using larval crustaceans hatched from cysts, and the test organisms are exposed for a very short period of time. This is about 15 minutes to an hour to the suspected water samples, after which a suspension of red microspheres are added. And in the control, the organisms ingest the microspheres, resulting in a deep red color of the digestive tract, and stressed organisms either cease to take up particle or they ingest at a much lower rate. So we can monitor it in that way. Then after exposure of these organisms, we use the results from all the different tests that we applied, and we determine a risk or a hazard category. Using a hazard classification system, as I mentioned, developed by Persona, whereby you can classify sites using the tox data of the non-diluted sample. The percentage effect of toxicity is used to rank the samples in one of 5 classes. So it's where class 1 is where none of the tests showed a toxic effect, which is significantly higher than that noted in the control. A class 2 is the statistically significant effect is reached in at least one of the tests, but the level is still below the 50%. A class 3, the 50% effect level was reached or exceeded in at least one of the tests, but it's still below 100%. And a class 4, the 100% effect is exceeded in at least one test, and in class 5, the 100% effect is exceeded in all the tests. Then the samples are weighted. The risks, each sample is weighted according to its relative toxicity level. So the higher the value, the values indicate that more of the individual tests indicated toxicity. So what I did is I don't know if you can, this is just results that we obtained from the first survey that we did, just to show that the normal tests, the bacteria, the algae, the fish and the Daphnia, we did get results. Adding the others, we actually got results that we didn't expect. So we need to also add additional tests. There's also other available bioassays that we can use that we would like to add, and just to see which of these will be more sensitive to which industry and which type of chemical. So we'll have to keep in mind that in vivo toxicity tests provide information only on the effects. We don't know what causes the effect. We've only had one round of tests, so we will have to investigate further with more trophic levels. We need to include other tests, as I say, to compare results and find the most suitable tests for specific sites and specific industries. But the most important, we have to compare these with the chemical results and the in vitro test results to be able to see which will be the most suitable. It's important to include these tests to support water management, to provide adequate information on the risks posed by known and unknown mixtures with possible secondary substances, to enable monitoring using the responses of whole organisms to detect and quantify the effects of groups of chemicals on toxicological endpoints of concern. And this approach will help to link chemical and ecological status, to detect the effects of mixtures of compounds in water resources and demonstrating their potential to affect aquatic organisms and human health, to detect hotspots of contamination, to ensure adequate monitoring and investigations, and to minimize the risk of overlooking hazardous chemicals, transformation products, and chemical mixtures. That's me.
Right. Thank you very much, Lisette, for that presentation. And if you do have some questions for Lisette, please do just drop your questions, comments in the chat. And then in just about half an hour or so, we'll get into the panel discussion where the very first thing that we're going to look at, it will be your questions. Right, our last presentation for the day is by Natalie, who is going to share some information on a stakeholder survey.
Okay. It seems we've caught up some time, which is good. Okay. Stakeholder survey, that's right. I have included this today because I was hoping that we're going to have lots of people here and online that will be able to take the time quickly, and if there's any questions, they can ask the questions regarding the stakeholder survey. So we initially started the project by sending out a stakeholder survey. Firstly, the GWRC approached us and asked us to send a survey out, and they sent out more than 300 surveys to various stakeholders in 35 countries. And these stakeholders included water utilities, municipal and private, any operational managers, researchers and experts. They also sent to policymakers and authorities, national, international, on health and environmental agencies, public health institutes and universities also were included in this, academic researchers, scientists and any expert groups, but also commercial labs and test suppliers in the water testing labs and suppliers of the testing kits. So they sent this survey out, I think it was in 2021 originally. And the objective of that was to share information on effect-based monitoring, raise awareness of effect-based monitoring and how it can support risk management, gather information on local practices and regulations in each country. So it was sent to not only places like America and Europe, but it was also sent to other countries in South America and us in South Africa who have particular water challenges. And also to get an idea of your perception. Did anyone know what EBM was? And if they didn't, did they read up about it and did they have an opinion on it? And the question, which practical information would be most relevant for future implementation? We did a questionnaire over and above that. So that questionnaire was sent to stakeholders in South Africa, but we also developed one for specifically our stakeholders. But just to give you an idea of the feedback, I don't want to cause any bias because I'm going to ask you to do the survey. Of these 300 forms that they sent out, they only received 63 replies. So the reply rate was incredibly low. The same for South Africa. It was 15% for about the 100 that we sent out. And this resulted in bias in the results in that most of the stakeholders that answered the survey were actually receptive to EBM. And who did reply, I will just have to turn here and have a look. So from the GWRC side or the international side, it was private water utilities that sent in the most replies, and the second was public institutes and universities. For us, it was actually pretty much the same between the policymakers and commercial labs, but it was the research scientists, those of us that are in this field and who feel very committed to this, that really did give a response. So unfortunately, it did bias the results a bit. So the responses to the questionnaires that was distributed to the South African stakeholders were comparable in their responses to the international GWRC questionnaire, and I can't give you those details because I don't want to cause any bias on the sending out the survey again. But we did recommend basically that we do need to do some knowledge dissemination first via workshop and public forums to put the idea out there into our water stakeholders so that they could think about it and then redo the stakeholder survey after the information session and workshop with the various stakeholders, which may give them a better understanding of what we are about. There is a link that was sent out this morning to those that were registered for the workshop. We also have a QR code for those of you sitting here that you can link up with your cell phones and do the survey if you would like to. And yeah, so those of you would have received a link. It takes about 5-10 minutes to answer. Ideally, if you have the 5-10 minutes now, it would be appreciated. The QR code will be put up on the screen now for you guys here. And if there's any questions while you want clarity on during the survey, you are welcome to ask. Have we got the QR code coming? Now, this QR code up here, if you're able to get it on your phone, it's not essential. There will be some time afterwards. We will give you a bit longer if you can't finish it today to complete the survey. But we would really like some active participation, particularly after today's workshop, from those of you that were attending on how you feel about this, and particularly our water stakeholders. I know there were some people from Limpopo that were going to log in today, so hopefully they are logged in and able to pick up this QR code. If not, please feel free to email me with and request the link again subsequent to the workshop. So shall we give them a few minutes? Okay. Are you all able to link in? Okay. It's quite quick, the questionnaire. Yes, please. The reason we asked you to redo it is we actually want to compare and see if it still looks and we get a similar response to what we got for the GWRC one versus our one, and if we actually did disseminate some sort of knowledge today regarding this. If not, then we can carry on with the panel discussion. Yeah. Are the guys online getting the feed? Yes, they are. Thumbs up. So, yeah. Okay. So they can do the QR code as well. Yeah. You need permission using the QR code and the link. Oh, dear me. You'll check it. Okay, we're checking it now. We checked it yesterday, but I didn't think of outside the organization because we all checked it and everyone could get in and do what they needed to do. So is there anyone out there saying they can't access it? Because we can't access it here because it's private. They can't access. Okay. All right, then maybe what we should do is if we can't access it and it's going to take a while, we will then give it public access and send it out after the workshop. And we can continue with the panel discussion then and answer some questions, if that's okay with everyone else. I think so. So if our panelists will please come to the front. Thank you. Lady, have we got the questions?
Yeah, so we are going to move on with our program and then get into the discussion. So this is exactly the point where we are going to pick up your questions and comments and try as much as possible to address them. But just before we get to that, I just want to stress the importance of your feedback or your participation in the survey, as it just does not help the research team achieve their project objectives, but also it helps practitioners in the sector so that as we move along the project, we make sure that we all have the same understanding in terms of the science around EBMs, that is effect-based methods, as well as their application. And for the Water Research Commission, this is also important because if there are any gaps in terms of understanding, then we know exactly that then we need to have more education and awareness campaigns. We need to have more stakeholder engagements. We need to have more knowledge dissemination workshops. And if there are gaps in terms of the actual practice, or if there are gaps in terms of the laboratory in terms of capacity and skill, then we know exactly who to raise that with. And then in terms of the training, we know exactly who is doing what in the sector. There are a number of private companies that also offer training in this area. I know that also Hesmary and her team, they also do that as well. So, I mean, we can be able to coordinate that as the Water Research Commission to make sure that everyone receives training. And if it is in terms of really where to buy what, where, and also that information can also be made available. So I spoke also about a report that is due to be released soon. So hopefully that report will also help us in meeting some of the gaps in terms of understanding in terms of effect-based methods. Right, that is that. So for everyone that has registered, we are going to make sure that we resend the link this time. We'll make sure that everyone can access it. And hopefully, Natalie, there is a space where there is other added information, just in case something is not asked in the survey. People will be able to write additional information. Great, fantastic. Fantastic, okay. So yeah, we'll be looking forward to then your feedback. That is after we have sent the link. So that is that on the survey. I would like to leave it there. And if you would like to forward it to your colleagues, please feel free to do so. Right, now we are entering our panel discussion. So before we do that, I am going to ask our panelists to introduce themselves. So, I mean, we are doing this within the scope of a WRC project. So some of them, they are heavily invested or they participate in that project. So it would be also maybe good to maybe the participants to understand your exact role in the WRC project. And then also feel free to expand on that, on your other expertise or other projects that are related that you are involved in. So I'm going to start with you, Natalie, before we get into the questions, so I was fortunate, I already got a glimpse for some of the questions. So I know that the
Will appear at
people
some point.
wanted to know who was who.
Okay.
So is that the link, is it working now? Okay. So I understand that the link is working now. So what I'm just going to ask is that you just try it. There's a QR code on your screens. If you can just get a screenshot of that, it should take you straight to the survey that we were talking about. And I'll just pause for a few minutes just to make sure that now people can access the survey and they are able to type in responses. So I'll start with our participants that are here. Are you able to? Okay, fantastic. So Natalie, the survey takes about what?
About 10 minutes.
10 minutes.
So it shouldn't take, unless you've got lots to write and lots of suggestions, which we will appreciate. But it's basically yes or no questions, and then there's a couple of long questions where you can add a little bit of extra. So, but we really would love a response from everyone.
Okay.
If possible.
Can I ask that those that are helping us with manning the screens here, that we hold off this process for now so that we can get into the panel discussion? And I'm hoping that the panel discussion will also help to realign people better.
Yeah.
And then just before we close off, maybe we're going to then have that 15 minutes where everyone will complete that survey, and then after which then we are going to close. That would also allow us the opportunity. Everyone has a problem
Then
or does not understand a certain question, we can be able to address it here and now. Right, can I ask then that we take down the QR code? I'm going to ask that we put it up again just before we close. And then we go into the panel discussion, specifically the questions that we have to address in today's session. So like I had already said, that while they are putting the questions up, I'm going to ask our panelists to reintroduce themselves. I know that there are those that had already done so. But yeah.
Right. Shall I start?
Please start, yeah.
Okay. I'm Natalie Annie Khan. I'm the Director of the Environmental, Chemical Pollution and Health Research Unit within the Faculty of Health Sciences at the University of Pretoria. We have, our unit focuses on health effects and exposures in humans and animals on as a result of exposures to environmental pollution and these chemicals. And within this WRC project, our focus is actually on developing the bioassays and toolbox and basically a decision tool in the end for the water stakeholders.
Right, thanks Natalie. Prof?
I'm Maria Peters. I don't think my mic is on. Should I switch it on? The audience here can hear me, I guess.
Is the mic working? Talk.
Am I on now? Can you guys hear me? Yeah, he says he can hear me. Do you hear me through this one? Oh, okay, all right. So I'm Maria Peters. I am a researcher in the Unit for Environmental Sciences and Management at the Northwest University in Potchefstroom. My main interest is detecting endocrine disrupting chemicals in the environment, mostly aquatic environment, and I also have a battery of reporter gene assays in my lab with which we usually investigate endocrine disruption as well as xenobiotic metabolism effects.
Thanks, next.
Hi.
I'm Lizette Swart.
Just bring it up. Oh.
Hello, I'm the Managing Director of Biotox Lab. We specialize in aquatic ecotoxicity testing, mainly at the moment for customers under their water use licenses that were issued to them by the Department of Water Affairs. For us, this project is also important because we've been experiencing that the water use license requirements are not based specifically on the industry-specific needs. They have to do these tests, but it's not necessarily the most suitable tests for their industry. So this will also help us in getting the most suitable tests as well for the industry, not only just for the project.
Thank you. Hi, I'm Shengeliz Wenyoni from the University of South Africa. Under the Institute of Nanotechnology and Water Sustainability. I come to this project as part of the cohort of people that do chemical analysis. Our lab is equipped with state-of-the-art, top-of-the-range facilities that ranges from the LC, MSMS instruments as well as the GCs and the ICPs. So we come to support the project WRC with the chemical analysis in that front. Thank you.
Hi everyone, I'm Katarina Frantzeil. I work with Natalie at the Environmental, Chemical Pollution and Health Research Unit at the University of Pretoria. And my area of expertise is the bioassays for EDC activity, especially the reporter gene bioassays.
All right. Thanks very much, everyone, for those introductions. So I hope that now that orientates everyone in terms of which question is directed to who. Okay, I am going to take the very first question that we received in the chat. So the first question is, did you take Annexure 3 and 4 of the hazardous chemical agent regulations into account? So I take it that is directed to you, Raylet.
Okay, yeah, so I took a quick look at this Hazardous Chemical Regulation Act. This is specifically for occupational health, so it is devised, it's geared towards humans and their exposure in the workplace. And it's usually a single compound, and there are a lot of regulation behind that for specific levels. What we are doing is we are checking what is ending up in the water, usually at very low concentrations, while the Hazardous Chemical Act refers to higher concentrations and single compounds. So we are investigating lower concentrations, those compounds usually, but not always, soluble in the water, and we quantify the mixture effect. I hope that addresses the question. Otherwise, please email me or contact me directly, and I can expand on that.
Yeah, actually, I'm happy that someone raised that question, because, I mean, like you say that these are regulations that apply more in, say, the workplace. So, I mean, some of the work that we've started doing, we are looking at water quality or water safety in buildings, for starters. I think in the workplace, it is a much bigger scope that I think spans outside the water domain, as you can expect to have some of the chemicals in the air, in the whatever furniture, and so on and so forth. So there is a wider scope of work that really is not part of this project. But yeah. If anyone requires more information, I think, yes, we can add on to that. Right, then the next question that we received is on Daphnia. And yeah, Daphnia magna is used globally as an indicator species, but D. Pulis is more precautionary in tropical climates like South Africa. So would you say your results have been more accurate if in South Africa D-police was used?
Okay.
Yeah.
Can I talk?
Yes, please go
Okay,
ahead.
the method has been standardized at 21 degrees. So, and we've also seen in interlaboratory studies between people using the different species that there's a good correlation between the two of them. So I'm sure that the Magna will be fine to use.
All right. Right. Yeah. Thanks, Lizette, for that. Then the next question, the million-dollar question: where do we get the toolbox? So that's for you, Natalie. I'm hoping that you can start telling people about some of the earlier toolboxes and then the current updated one, which was part of 00165.
Okay. So thank you for the comment on the presentation. We are not currently monitoring waterborne pathogens with zoonotic potential. Ours is looking and using cell lines, looking for hormone receptor-mediated effects. So that has not been, the waterborne pathogens have not been looked at in the toolbox. I think it would be a standalone toolbox. Our toolbox started firstly with estrogenic activity and bioassays there, where we had the yeast screen and the T47D, which is a mammalian screen line, and a reported gene, as Katerina called them. We are then expanded to include the thyroid assay, and now we are adding the other assays in our toolbox that we have. We are doing the oxidative stress with using the ARE37 cells, or 32, I think it is. It's arrived in our lab about a month ago, so I'm still familiarizing myself with that. And then Rialette has her battery of assays, which is different to ours, and the guys at Stellenbosch University use the yeast screens. So the assays are actually in 3 different labs around the country in 3 different institutions. So there's going to be some thoughts around how we're going to manage this in the future with regarding to capacity building and having perhaps a virtual type of lab. But that's in the future. I don't know, is there anything else you want me to touch on here?
The other toolboxes that are available, the other reports that have been published.
The thyroid one and the estrogen one. Yes, the estrogen toolbox, that was published in 2011, and that is available on the WRC website. And then the additional thyroid, that was a test that was added to the toolbox in 2017, is also available. And then our current toolbox features an array of assays looking at xenobiotic metabolism, hormone receptor metabolism, and also oxidative stress or adapted stress responses. And those will include full methods of those bioassays. So it's not just an endocrine disruptive toolbox that we put together now in the end. It actually looks at more modes of actions or endpoints following the adverse outcome pathways of metabolism and what happens to these chemicals along the way and at the pathway through the animals and humans ultimately in the end. But one must always just bear in mind it is very difficult to make a direct link to say this is going to be exactly that in humans. These are screening tools and they are indicators, which is where our effect-based trigger values come in. To give you an example, we developed here in South Africa with Bettina Genter a estrogenic equivalent trigger value for our drinking water at 0.7 nanograms per litre estradiol. That was used using our yeast assay at the time, if I'm not mistaken, and using South African biometrics to develop that trigger value. So it differs slightly. It's close to the international one, but it does differ slightly, and that is specifically for the estrogen test. So ultimately, in the end, that is something we will do once we've decided on exactly which assays we have the ability and capability to do accurately and with confidence here in South Africa, and then we will do the risk and develop our trigger values, which should probably be in line with the world's trigger values, but differ potentially slightly. And yeah, but that, the toolbox, as Nonhlanhla had pointed out, it's not 100% finalized yet. It's still going through the processes for publication, but we will let the people that attended this know exactly when it is out there and available for public consumption and comment. And we are busy with the next projects using these assays in case studies. So that will also give us an idea and assist us in developing our effect values, but also how feasible these assays are, so that we can present right at the end a tool for our water stakeholders and boards and municipalities that they can use in the different scenarios that they face.
Right, yes, thanks, Natalie. I think from my side, I can probably commit to say that before the end of the year, we will have the fact sheets available for download on the WRC website. So these fact sheets are a compilation of a number of bioassays that can be applicable for water quality monitoring. All right. I just wanted, before we move on to the next question, which will go to Lizette as well, to just add a little bit. I see that there's a question about waterborne pathogens with zoonotic potential. So, I mean, this is outside the scope of this project, but, I mean, having been involved in similar research, probably just to give some feedback to whoever asked that question, we have a couple of projects that the Water Research Commission with other partners, including NICD, MRC, that are doing on the surveillance of waterborne pathogens within the environment. So those studies are available, I think, online if you go into the individual pages, web pages of these institutions that I've mentioned. So even at the Water Research Commission, we have some active studies at the moment where we're looking at, so most of them, they were built around the surveillance of COVID-19. So we've sort of expanded the scope to look at other emerging pathogens, which might cover those that have zoonotic links. So I would encourage whoever asked that question to, we have the Water Institute of Southern Africa conference that is coming up. Most of those studies will be shared there. So for your information, please just make sure that you look up the WISA program, and there might be a few that might be presented there. All right, can we move now to the next question, which is on Daphne as well. I'm not sure if, Lizette, you've had time to look at the question itself.
No, but I think we've answered it with the previous question. It's basically the same. It's based on the standardization of the method temperature. It won't make a difference.
Okay. All right, then there was a request for contact details from the first session. I'm not sure if, Naledi, you know exactly when that came. Natalie? First session. Okay, okay. Yes, your contact details. Yeah.
Yes.
Can you include them in the, are they in the link that we are going to send out?
Yes.
Fantastic.
Sorry, thank you. My details are in the survey. There's my email is in there, but it's also in the link. It should be in the link and also the advert.
Okay.
Um,
Yeah.
So, but otherwise, yeah.
I'm sure you're
It-
famous by.
I don't know about famous or infamous, but it's basically my first name and full stop and my surname, and then at up.ac.za.
Okay. Yes, if you did not get that, I promise you, if you just Google Dr. Natalie Anekhan, you will get the details. And if you can't, if you contact me, I will be able to pass on the details. At least I have Natalie's permission now. Right, then there is a question still, Lisette, on Daphne. So there is another project that is being done by Northwest around glyphosate, and the results that they've gotten there is that DPUL is more precautionary and should be used instead of Daphne magna. I'm not sure if you still want to add, because, I mean, yeah, it keeps on coming up. I think the best that I can do is, I'm not sure if you would be interested if I can link you up with the project team. I mean, even Riley next to you, I'm sure she can be able to link you up with Surani as well as Tarin, who are working on the Knowledge Hub.
Yeah, so this is a bit confusing for me because I am on this glyphosate project, but we haven't tested it on Daphnia. Definitely not. So we are into investigating the levels of glyphosate and AMPA in the aquatic environment and in soils, but we haven't done any exposures with Daphnia. So the Knowledge Hub I know is run by Taryn, who is now from UNISA, Taryn Botha, Dr. Taryn Botha. So yeah, I can maybe make a comment on the difference that people pick up on between these two species is when you do only one compound, a single compound, you will invariably find different responses for the different organisms, different species. But remember that we are investigating a mixture of effects. So we do not single out a single compound. We work with a mixture that is found in the environment. And what Lisette and the other people do with their methods is that they use raw water as is. It's not just a single compound that's being tested there.
Okay, thanks. There's also, I don't know, who can run quickly and give Hesmary the microphone as well. I'm happy that also maybe this question has come up around about this time because, I mean, there is a scope, part of the scope of the project is actually to test the application of some of the bioassays. So I would maybe encourage also Natalie and her team to maybe look into this. I also want to put Karabo on the spot because I know that she's also doing another project on PFAS. She is going to be also investigating the application of bioassays on PFAS. Then, yeah, can I give also Hesmary an opportunity to say something on this? Yeah.
Thank you, Nonhlanhla. The short answer is that internationally, Daphnia magna is used for the environmental samples. All over the world, everybody's using Daphnia magna. The suppliers have even stopped producing Daphnia pulex. So that to me is the conclusive answer. And I agree with Rialette. If you start looking at single substances, you might find that pulex is more sensitive. But even in our case, we're moving towards Daphnia magna.
All right. Thanks for that, Hesmary. Natalie, do you want to add?
I was just going to add to it to say that this is what we're doing our case studies for, and if it's not going to be a suitable assay, then we will hope it would come out. But as Hesmary says, if it's an international method and that seems to be the best and that's what's available, then we may well have to do that. But that will come out at the end of the project.
I was going to ask that in terms of comparison, if the golden standard, the global standard is Daphne magna, and there you are, you've used pulleys. Would you be able to compare these two results or not? Because I think that is the other very important, if we have results, or there has to be certain specifications on when can deep pulleys be used.
Is it on? So just to come back, even in our case, in our proficiency scheme, we're still using Magna and Pulex to accommodate the labs that historically been using the Pulex. And even there we see for single chemicals that there's very little difference in the EC50 values. So sensitivity being very much the same. So I know that even universities like Rhodes have started looking into indigenous organisms. And coming back to what Lizette showed you briefly, the results from this specific project, that we found that something like Tamalocephalus, that's another invertebrate, was more sensitive than Daphnia magna and Daphnia pulex. So again, coming back to what Natalie is saying, every situation is going to be different, and we need to look what works for that situation. But there is a basic set of battery of tests that we can use, and that's proven over time.
Okay, right. Thanks, Hesmary. I hope that maybe settles the question for now. I think the understanding is that obviously Daphnia magna is the standard. And obviously there would be, if you want to, I don't know, expose deep pools as well, you can, obviously, but if you want to be able to compare results with other international results, then yeah. Anything to add?
No, not to that.
Okay. So yeah, also the other thing is that, so that would also be tested as part of the second level of the project in the case studies, so we would have that feedback at a later stage. All right, the next was a request for contact details once again, and I see that the team has already shared Lizette's email address in the chat.
Oh, have they? That was quick. I didn't see that, because I was going to say what we'll do is we'll put the panel's details in an email out to everyone who was registered so that they can have the details of all of us to contact us, if that's fine with everyone else, yeah.
I think that would be fantastic, because I think, like I've said before, I think in another platform, that the first part of the work is done, the fact sheets and everything, making sure that everyone understands what bioassays are, when and where can they be used. And then the second part of the project is now the application part. So if anyone would like to participate in the project in whatever format, it would be good that they get in touch, and then we can explore the scope of the participation. Do you want to donate samples? Do you want to commission your own study within your municipality, or whatever the case may be?
And give us more money. Always welcome.
Yeah, that too. All right, I'm not sure if there are any questions from our audience here.
Okay, so this comment relates to the fact that you're looking at a bioassay and looking at a mixture-related observation. The pity that I see is if you do big data analysis and you know where the compounds are of the admixture, and you also, for instance, whether it's metals or whatever, you would be able to define sentinel or most commonly observed substances within your mixture, and that would inform strategic plans. For instance, if it's a mining industry or whatever. So for me, there's a lot of information that, and I haven't been reading in this field, a lot of information that may get lost in the process. So I would suggest something like a Bayesian network analysis or any form of, first of all, machine learning, either blind, and then where you do the teaching and where you direct the analysis, statistical analysis. Okay, I understand it is expensive, but I really think it's a body of knowledge that could really, really add a lot of value.
Yeah, that's a very interesting comment that you are raising, because I think what we've done in the past is do almost more the same of everything. Every maybe year we fund projects where we are still screening in the environment what's out there, and then the next year, because I mean obviously chemicals, the list grows bigger and bigger. So if we can develop a method for predicting what is likely to be the most prevalent chemicals for, say, the mining industry, other chemical industry, or even if you are a water utility, you are abstracting water from the nearest dam or river, what is it that I should be worrying about? That would be very fantastic. I think we haven't gotten to that stage as yet. And I think, as you are mentioning, it would be a very good area to go into. Because I think what we have invested in right now is that we have, I mean, you've heard there is a project that is currently ongoing where we're trying to get up and running a knowledge hub where everyone who's doing this monitoring can sort of deposit that information there. But the statistical analysis or the data analysis, the big data analysis of that is something that we have not done. We more or less expect people to say that, okay, I am in the Val, so I have 420 chemicals that might be there in that resource.
I think that's a very relevant point, and I think that's also one of the endpoints that we're looking at, because together with what we are doing here, we've got the effect-based bioassays in vitro and vivo, and then Lisa is going to be doing the chemical screening. So I'm not going to find the same chemicals from Limpopo province as I would down in the Free State or in the Western Cape. And I think that is where the big data mining would potentially come in, because it will be our data plus Lengualisa's data working together to tell us what are the chemicals we need to focus on there and who are the primary polluters in that area.
Yeah, we get asked that question so many times as well. I mean, like WRC, you funded so many of these studies. What can you tell us at the moment? Yeah, unfortunately, it's in the reports there, somewhere in the reports. So what we did, I think, a couple of years, 2 years ago, is that we went through a manual selection and prioritization exercise by applying is it toxic? Has it been observed in more than 2 places around the country, and so on and so forth, of which then we derived a shorter list of what we called the prioritized list of chemical contaminants. But obviously we understand that it is not, applicable everywhere. It's just a short prioritized list, which serve as indicators, not necessarily a true reflection of what you would find there. Yeah.
Okay, so I just want to add about the advantage of the bioassays, especially if you're at a site where you don't know what to expect or what to find. You can do the bioassays to see, is there a potential problem or isn't there a potential problem? And then, say for instance, we get androgenic activity. Then you know where to start looking for potential pollutants, or you can get an idea of where to start looking for what chemicals to maybe screen to see where the problem lies. Okay.
Yeah, I also want to put Lengualiza on the spot there, because I'm happy that you said that, Katerina, because we've been hearing that the advantages of bioassays is that they can be good screening tools. You do the bioassay, it just tells you, is there an adverse effect, yes or no? And then the second level of investigation, obviously, is the chemical investigation. because, I mean, the bioassays would give you that there is an effect which could be due to a single chemical or a combination of chemicals. So for you now, if you are in the water treatment space, you need now to design a treatment technology or retrofit your existing plant with a technology that should be able to eliminate that problem that you would have would be causing that adverse effect. So then that's where the UNISA project comes in handy. So maybe you can elaborate then the series of steps and to what level of detail can we get to, other than just the identities of the chemicals, can we also know the concentrations and so on and so forth?
Yeah, thanks for the opportunity. Yes, our approach, especially on the organic contaminants, we have set up a system that can measure. Well, we do untargeted analysis first, where we screen using high-resolution mass spectrometers, and the sensitivity of that instrument in terms of the on-column picograms or the on-column amount, we can go up to 1 picogram on column of rezapine, and it gives you a signal-to-noise ratio of 500. So it's very sensitive. So we have set up in such a way that we do a data-dependent analysis on the MSMS experiment. We screened for even unknowns. So the first port of call is to really get an array of chemicals that are in there. Then once we know, obviously, quantification will require that one. I'm happy that there's somebody doing PFAS. Will require that then one already starts to do a quantification approach, where you use the issue of the standards, internal standards, trying to balance the volume corrections and the like. And you determine your quantification range, and then you can report the concentrations accurately. That's the LC part, but we also have the GCMS systems. That again, these ones, we have one that deals with nominal mass. We have a NIST library in there. But if you want to investigate the unknowns and they are not in the library, we have a natural T that helps us to elaborate, to structurally elucidate the compounds, and then a fingerprint to say there is this chemical structure that we see, even if we do not know the names. But to add on, we have spoken about metals. Reality was speaking about metals. We also want to know what kind of metals are in there. So we're using the ICP-MSs to try and identify the inorganics that are in the sample. So our approach, other than quantification, we do qualitative analysis using those high-end equipment. But there is the aspect of sample prep as well and collecting appropriate samples. So we do have the SOPs. If you are going to look for organics, volatiles, and whatever, this is how you approach it. But we are combining that with 3 approaches of sampling. I know there are people that go to the field, grab a sample, bring it to the lab and do measurements. But we are incorporating the aspect of doing a composite sample where we do a pool sample over a period of 24 hours. To add a spin to that, we know that there are some passive sampling technologies that have been used over time to monitor different classes of organics. So that's especially in those rivers and areas where we cannot install automated samplers to actively sample over a period of time. We will then leave those samplers to accumulate the toxins and bring them to the lab. Obviously, those samplers need to be calibrated, and we use performance reference compounds, which are chemicals that we add in them. But for the bioassay part, those samplers that we deploy for extracting contaminants so that we expose them to bioassays, we do not add any chemicals in there, obviously, it will affect the responses. Generally, that's all that I can say. I'm not sure whether I can add on this. Thank you.
All right, yeah, thanks, Hlengilizwe. And yeah, what Hlengilizwe has just explained, as I said, that it is part of the next portion of the project. So hopefully once the project is finished, we would have a much more comprehensive toolbox that is going to cover from your sampling, the SOPs that Hlengilizwe has spoken about, sampling for bioassays, sampling for chemical analysis, and then also if you would want to determine the fitness for use of a particular water resource or source, and there will be a decision-making tree, let me call it that at the moment, to help you guide you which tests or which bioassays would be more appropriate for you to arrive at the answer that you want. And then also some guidance on how to interpret the results and also some of the recommended actions that you might want to take, especially for those that are in the treatment, water treatment industry. All right, I see that there is one last question from online participants. Someone wants to know, could managers working in environmental government programs that regularly visit polluted water bodies learn to do routine water quality monitoring checks and interpret results, bearing in mind some of us don't have chemistry backgrounds? Right. Can I pass on that question to you? Do you want to start, Hesmary? How easy is it to train people to be able to do bioassays and interpret the results if they do not have chemistry background?
Okay, so the quick question again, I don't like long-winded answers. I can't talk for Natalie and Riolette stuff, but on the aquatic toxicity side, it's very easy. It's a very basic test. You don't need a lot of training. It's something that can be easily taught in the lab, as long as you've got an environmental room where the temperatures are kept at 21. But really easy tests. I think the major thing to train is how to use a pipette. But if you can read pictures, you can do the test.
All right, thanks.
Very easily, and it has been implemented in a lot of labs over the last 20 years, so it's very well established as well.
Yeah. And maybe just before, okay, even maybe Lizette can also ask, let's start maybe with the in vivo. The training, are there a lot of institutions, academies that provide this kind of training? Is it something that everyone, and someone can go into the web and find out where the next training for in vivo assays? Let's start with in vivo, since Hesmary said they're the easiest.
Yeah, we use the test kits that Hesmary imports for us, and it's like, as she says, if you can read, you can do it. There's pictures saying, now you put this there, now you put that there. So it's really to go to another institution to learn that. And she provides the training on that as well. And I think the NLA sometimes provides some training on that as well. There are institutions providing that, but it's really, really straightforward and it's not rocket science.
Okay.
Yeah.
All right, thanks.
The quality assurance from SANAS. So if it's implemented in the lab, SANAS provides a very good audit function to make sure what you say you do is what you're actually doing. And we also got proficiency schemes running in the country that you can actually compare with different laboratories. And we're adding more and more laboratories to the proficiency scheme, and we're starting to adding more and more methods to the scheme as well, which shows me that it's a growing field.
Okay.
There's also universities that's getting involved, more commercial labs that's getting involved, and the water boards, the big water supplying companies, all have their in-house laboratories. We're seeing more and more research done by master degree level So kids coming from universities that's already got background in toxicity, which we didn't see 20 years ago. UNISA has got a training program. There is more and more being available. So it's not just me.
Thanks, Esmery, for that. So I hope that provided a bit of some context that if you are a government department, you have a laboratory, you can participate in the proficiency schemes, and also you can get your laboratory SANAS accredited. I think that would be good for the audits, the quality assurance, to make sure that everything is done correctly. And obviously, if your lab is SANAS accredited, then you can almost like take your results out there because they would have that quality assurance component in them. Can I ask how easy will it be to have some information on where training is provided?
I just want to make an advertisement first.
Okay.
So, at the Unit for Environmental Sciences and Management at the Northwest University, we have an honours program in aquatic health. So, if you walk out there, you have a basic good understanding of toxicology in the environment. Okay, but to answer the question about how easy it is to do what we do on a regular basis, so you really need a well-equipped tissue culture lab. That's the first requirement. And once you have that and you can maintain good quality cultures, then you're halfway there. The second step would be to be able to interpret the results. And I know that the OECD are working on at least establishing a worldwide method for the cell line I call the H42E one. They call it AR Calyx. No, AR Calyx. That's a commercial line, but the one that we have is a research line, and they are in the process of establishing a similar to SANA's method. So if you learn how to do that and you follow their guidelines very well, and you can do basic tissue culture, then interpreting the results is maybe you spend 3 months in any of our labs, and then you will be able to do that. Right. Natalie, you want to answer anything? Katarina?
Okay, yeah, so I mean, I'm going to go back to that report because now it's on me why that report is not on the WRC website. Because I think the research team, they put in very, very good information, the basic information on some of the tests, what you need, what sort of equipment you need. The other permits, the other thing is permits that you might need to import some of the cell lines. So all that information is there. So now I am going to try by all means to get it out as soon as possible. If I said before the end of the year, in a couple of weeks.
The end of the year is coming too quickly. But if I just want to add, if I can, is that the reason we did the fact sheets is to give you an overview of what the assay is about and what it's going to measure. The toolbox goes right down to the very nitty-gritty of everything. It has every single step that you need to follow and do, written out in full, catalogue numbers, where you can get the supplies, where you get your permits, who the contact person is, and then also we put our contact details that if you want assistance or training within our labs, then we've included that there. So it in the toolbox itself, which is coming out, the details. It's all in the details there, but the fact sheets give you a nice overview.
I think, okay, there's one last question from Dr. Matabula there.
Thank you. Some of the answers have already been provided by my learned colleagues. And in fact, I was just going to ask the question in terms of the status of effect-based water quality assessment or monitoring, you know, and I hear that the processes are quite simple and straightforward, but on the other hand, I'm thinking application. Where are we in terms of applying this in the country, you know? If we have this simple and straightforward technologies, if I may call them, why are we not adopting them? Where is the problem? And is it behavioral issues? Is it, you know, I used to work in the water industry, you know, it's very typically not easy to introduce new technologies. Is that the problem, you know? And another aspect is just to bring in another aspect to that question. How do we compare to the rest of the world? What is the status of the effect-based water quality monitoring out there? Maybe starting with the continent and outside the continent and the likes of Europe and America. Thank you.
Yeah, over to you, Natalie. Yeah, you can start, and then Natalie can.
Okay. So I'm very proud to say that we are right there, up there with the rest of the world. The battery of aquatic toxicity tests that we're using in South Africa is the same battery of tests that we're actually using in Canada, US EPA, ISO, OECD, and they're definitely, we're correlating very, very well with the rest of the world. So we're using the right methodology. Our aim now is to improve our methods, to make a little bit of a bigger battery. It's very well implemented in South Africa. The main source of implementation is the water use licenses. And especially in Gauteng, KZN, City of Cape Town, not as much the Free State, not as much the Eastern Cape, not as much Limpopo, but the main centers are definitely implementing these aquatic toxicity tests. So widely used in the water license sector. You won't get a water license if there's not toxicity in it. The fact that there's so many commercial labs being set up tells me there's money in it. So they all have got their tox labs that's doing the work for them. And it goes very well with the chemistry, the micro, the SAS type of testing. The thing that I'm the most proud of is that we've now got our own ISO committee established in South Africa purely for the biological tests. So we are making sure that South Africa is aligned with the correct methodology. And we've got full say, and we're using it very well at the moment, where there's new methodologies coming out in nanos, microplastics, that we have got an expert on that committee saying, we are happy with that methodology, or no, we don't want to, we want to change the methodology with this and this and this. So we're going to the meetings overseas, and we're bringing that information back. So definitely well established in our country, and I'm very proud of that fact.
Yeah. Thanks, Hesmary. I'm hoping Natalie can maybe shed some light on the services side, especially drinking water production. I wouldn't want us really to keep this for longer than 13:30. Okay, can I just give Natalie just to probably say something on the services side, especially drinking water production?
With our bioassays?
Yes.
So currently in the country, there's no a water board or water lab that is doing our type of assays. They are in academic institutions at the moment, but I think that is going to change at some point. Internationally, the United States is using effect-based monitoring. Europe is using effect-based monitoring. Asia is starting to use effect-based monitoring. South Africa is really introducing it into Africa. And And that is why we also have this toolbox that is for South Africa. So it means what can we afford here that is in line with the international protocols and programs that we can start implementing over here. The National Toxicology Program had mentioned including the yeast screen many years ago, but that is your basic screen, so it has been mentioned and it is out there, but the capacity at the moment is a little bit difficult. So we got to think a little bit out of the box regarding that, because to set up your infrastructure for the lab is quite important because it has to be right, because it's extremely sensitive. So we're almost thinking of having a virtual type of setup that there will be pivot labs doing samples in the Cape will go to this lab for extraction and then will get disseminated to the various labs. Our issue is that most of our licenses are for academic use, but we get around that because there are a couple of water boards that do these tests, not every month. They do it, say, twice a year or every quarter. So they are bringing it in so that when their clients ask, they can say, we are monitoring, not just every month, because the capacity to monitor everyone's water samples every month is also impossible. The academic institutions don't have that. But I think if we come together with a consolidated toolbox and a good mandate, I think it's, we will be able to put something together in the long term to develop and have these put into legislation. I spoke to Leanne the other day about the SANS 241, and she said some of the new stuff's already caused a lot of controversy. Because I wanted her to speak today, actually, and she said, no, we're going to have to do this with baby steps. So, well, we're getting here. We started in 1999, baby steps. It's now a toddler. Toddler's a bit faster, so hopefully we'll get there quickly.
Thanks, Natalie. Did you still want to say something?
Is I'm very passionate to get this into the SANS 241 on the biological side, and I know Nonhlanhla will know we've been talking about that over the last couple of meetings from SANS 241. And I agree with Natalie. I said it won't happen in the next 10 years, but we need to start doing the homework, and that's where I see this project, is doing the homework. I just want to know from the panel, how do you see this being incorporated in the SANS 241? Like you said, Natalie, baby steps, but how do you see it happening in the next 10 years?
Sure. That's a difficult one for me because I'm not very much involved. I've only sort of started getting involved in the SANS 241 now. But I think what's going to come out also from this case study that we're doing, we are going to be able to pinpoint what is your starting point for a lab that is not fully equipped for something versus a lab that is more equipped. A lab that is better equipped and more sophisticated can do more tests, obviously, than a lab that's not as equipped. So you will start off with your basic tests, I think, in the rural areas, something like a yeast screen with waste-treated water. That's a tough, easy, not a finicky screen, but it's going to give them the basics to start with. So I think you're going to also get the water boards doing exactly as one particular one has done. Pick a lab and send samples regularly to an academic institution, because we are there to build capacity. So we do have people from those, or students from those boards or municipalities that come in and can get training in our lab for their project, so that they go out with training. And that is the only way we're going to build capacity, is by sharing the knowledge that we have, and not necessarily just as someone who's a BSc honours student, but someone who's a water expert that works in a lab that needs specific training. But it is going to take time. And the labs, our labs can't take 20 students at a time.
Yeah,
And cost, yeah.
yeah.
But also...
Yeah, I think also just to add, I think being on the Sons 241 committee, and I mean, most people would know that Sons 241 itself has evolved quite a lot. It used to be just a document with limits that do not exceed this limit. This is the limit for this and that. But over the years, it has evolved into a document that has a how-to and then the limits. So the how-to part, it covers most of what we call the water quality risk assessment, the water safety planning approach, or in other areas, what they call HACCP. So the very first point or step in water safety planning is identification of all hazards. So that's where then the screening tools come in handy, because then they give you that immediate answer. Should I worry? Should I not? What are my biggest problems? And then once you skip onto that stage, then you get into that monitoring. What should I monitor? What should I not monitor? Because it is not a problem in my catchment. Anyway, yeah. Anyway, that's that. I would like to then thank everyone. I would like us to close this session, but with the understanding that our contact details, I'm hoping that mine also, they are out there. If you'd like to get in touch, whether you are interested to participate in the project as a reference group member, or you are a municipality or water board, you would like to have a discussion on participating, how you can participate to be part of the project, or your government, you would really like to get involved as early as possible so that you can understand what the policy implications are in your area in terms of effect-based monitoring methods, please do get in touch with us. And then I promise that towards the end, we will pause a little bit so that we can give people time to look at the survey. I hope that people did have that on their phones. And also, if you are online, you will receive the link in any case in your email. I'm not sure if we're going to send a new link. Okay, the link has been, I think the link has been fixed, so it's not broken anymore. So if you click on that link, it should take you straight to the survey. So I would want to encourage everyone once again to please participate in the survey, as it will contribute immensely in shaping the project going forward, and also to make sure that we are taking out the right information or engaging the right stakeholders throughout the project.
Someone is going to talk about PFAS testing. Someone who's involved in.
Yes, so there are a couple of projects that are ongoing within the WRC, and some are not funded by the WRC. I'm sure you also have students, and also Raylet, you're also involved with the Northwest project on glyphosate. I don't want to put Karabo on the spot. So Karabo is doing a project on PFAS. So she will also be investigating the application of bioassays to look at the effects or the human health effects of PFAS in the environment. Can I at least commit to another session, either sometime next year, so that we can be fair, give them some time to prepare. At least I have said now that this kind of work is out there. If you want more information of the project, yes, I can definitely give that information. But can we give the students? There are a couple of them. We have projects from microplastics to whatever other contaminant that you can think of that are ongoing. So can I at least commit to a separate engagement in the future where the students can then share the work that they are doing. But for now, I think just know that there is a project that is looking at that. It's a much bigger project that is monitoring PFAS around the country.
Sure, I think that's a very good idea, and I think there's so many projects, because I'm thinking of Siobhan's project, Karabu's project, our students' project, and I think if we have a water research day with our students, I think it will be a good thing and give them good exposure.
Definitely.
So we'll definitely do that next year.
Yes, we can do that for June, Environment Day next year. Yes, we can showcase all the projects at least that would give them enough time to prepare and also look at the results and be able to share some meaningful information. All right, we have reached the end of our program today. So first I want to thank the project team for getting this event together. I also want to thank our panelists for imparting the knowledge that they did today. And then also further emphasize that there is a lot of work that is ongoing. So like I have already committed that we are going to have similar engagements in the future. It is part of the project scope anyway, from time to time, to take out the information out there to make sure that we do not leave the knowledge dissemination towards the end, where then we have to almost start educating people from the start. So there will certainly be another engagement. Similar to this one, we'll be sharing more information on effect-based methods. I'm not sure from your side, Natalie, if you have any final remarks.
I just want to thank you for jumping in as chairperson this morning. Thank you so much. You always do it so eloquently and so well. And thank you to everyone who attended today. Much appreciated. And stay safe.
All right. Thanks, everyone. Please do complete the survey and send back your answers. And those that want to get in touch, please do. Bye-bye for now.